Open your refrigerator and look at the vegetables inside. Crisp lettuce, sweet carrots, a solid head of cabbage. Now take away the grocery store, modern farming, and 10,000 years of human choices. The lettuce grows prickles and bleeds bitter latex. The carrot shrinks into a woody root, and the cabbage head disappears entirely. So how did farmers with no genetics, no microscopes, and no idea what DNA was redesign wild plants into your salad? In 1926, botanist Nikolai Vavilov mapped crop diversity across ancient farming regions. His maps revealed the fingerprints of an experiment conducted over thousands of years by people who had never heard of DNA. Eat the plant, save the seeds from the useful accident, and repeat. Start with lettuce. Modern lettuce looks almost helpless. Its leaves are broad, watery, and easy to tear. Leave it unattended in a field, however, and it begins revealing what it once was. The plant bolts upward. A stalk rises from the center, sometimes more than a meter tall. The leaves narrow, their edges become tougher, and small prickles can develop along the underside of the central vein. Cut the stem and a milky white latex appears. That is why lettuce belongs to the genus Lactuca, a name connected to the Latin word for milk. But this is not milk meant for you. Wild lettuce species use the sticky, bitter fluid as protection against hungry animals. Compounds in that latex helped make the ancestral plant a much less inviting mouthful than the mild leaves in your refrigerator. One likely wild ancestor is prickly lettuce, Lactuca cereola. You can still find it growing along roadsides, disturbed ground, and field edges across much of Europe, Asia, and beyond. It looks less like lunch than something you would pull from a garden and throw away. Yet people were interacting with lettuce thousands of years ago. Ancient Egyptian images from the 3rd millennium BCE show tall, upright lettuce-like plants associated with food, ritual, and the fertility god Min. These were probably not compact supermarket heads. Many likely had long stems and narrow leaves, and some may have been valued for oil-rich seeds before generations of selection emphasized edible foliage. Imagine choosing among them. One plant has softer leaves, another produces less bitter latex. A third delays flowering, staying leafy for several extra days. You keep seeds from those plants, and suddenly evolution has a new judge: you. Natural selection rewards a wild lettuce that survives drought, insects, and grazing. Human selection rewards a lettuce that remains tender while you decide what to make for dinner. Those goals are not the same. Over centuries, people pushed the plant away from survival on its own and toward dependence on cultivation. But the most startling vegetable transformation may be hiding under the lettuce. Pull a wild carrot from the ground, and you will not uncover a long orange spear. You will usually find a thin, pale branching root. It may smell recognizably carroty, but it is tougher, woodier, and far less rewarding to chew. Above ground, its delicate white flower cluster can resemble lace, which is why wild carrot is often called Queen Anne's lace. There is also a dangerous catch. Wild carrot belongs to the same plant family as poison hemlock and other highly toxic species. To an inexperienced forager, a mistake in identification can be fatal. The familiar carrot smell, hairy stems, flower shape, and other traits matter because it looks close enough is a terrible survival strategy in this family. The carrot itself was not originally orange. The cultivated carrot was probably domesticated in Central Asia, with early forms grown around the region of present-day Afghanistan and neighboring areas. Those carrots were often purple or yellow, and selection initially may have favored aromatic leaves and seeds, as well as enlarged roots. Then people kept choosing roots that were less branched, less fibrous, and more pleasant to eat. Purple carrots carried pigments called anthocyanins. Yellow varieties carried different pigment profiles. Orange carrots, rich in carotenoids, became especially prominent in Europe during the early modern period, although the popular story that the Dutch invented them solely to honor the House of Orange is much neater than the evidence allows. The real story is stranger and more impressive. No single farmer designed the carrot. Countless people nudged it in the same direction. Each season they replanted the biological accidents they liked. A slightly wider root became the parent of wider roots. A sweeter root was allowed to reproduce. Roots that split into twisted fingers were passed over. Eventually, a scraggly storage organ became a bright, crisp package of sugar and water. And then there is cabbage, which hides an entire produce department inside one species. Wild cabbage, Brassica oleracea, grows naturally along parts of Europe's rocky coasts. It survives salt spray, strong wind, thin soils, and exposed cliffs. Its leaves are thick and waxy, useful traits when the sea is throwing moisture and salt at you. It is edible, but it does not naturally form the dense, heavy ball you recognize as a cabbage. That ball is a human obsession made visible. Farmers repeatedly saved plants whose central leaves clustered more tightly. Generation after generation, the cluster thickened until the plant formed a compact head, but other farmers wanted different body parts. Select the side buds, and you move toward Brussels sprouts. Favor enlarged flower buds, and you get broccoli or cauliflower. Choose a swollen stem, and you create kohlrabi. Keep selecting large, loose leaves, and you get kale or collard-like forms. Cabbage, broccoli, cauliflower, kale, Brussels sprouts, and kohlrabi are not merely relatives. They are domesticated versions of the same species, sculpted into different shapes by human preference. One wild coastal plant became 6 vegetables because people kept asking it different questions. Can your leaves grow larger? Can your buds grow tighter? Can your stem become swollen enough to eat? The plant answered through variation, and farmers preserved the answers they wanted. But cabbage never surrendered all its defenses. When you slice it, enzymes mix with compounds called glucosinolates and generate sharp-tasting chemicals. That chemistry contributes to the bite of raw cabbage, the heat of mustard and horseradish, and the unmistakable sulfurous smell that appears when some brassica vegetables are cooked. To the plant, these are not culinary features. They are part of a defense system. Damage the tissue, and chemical components that had been kept apart collide. It is a microscopic alarm triggered by your knife. Humans did not simply remove every unpleasant trait. Sometimes you liked the defense. A little bitterness made a leaf interesting. A sharp chemical burn became mustard. Aromatic oils became seasoning. The boundary between poison, medicine, and flavor often depended on the compound, the dose, and how the plant was prepared. That made domestication a negotiation rather than a total victory. Make a plant too defenseless, and insects consume it before you can. Make it too bitter and you refuse to eat it. Farmers repeatedly selected a compromise. Tough enough to grow, mild enough to become dinner. You changed these plants and then they changed you. Larger, predictable harvests helped support villages. Storable roots carried people through lean seasons. Leaf crops added variety to diets. Seeds traveled through trade, conquest, migration, and marriage, carrying local preferences with them. Every region continued the experiment. One community favored color, another favored storage life, another tolerated bitterness because it suited a familiar recipe. This is why traditional crop varieties can differ so dramatically, and why Vavilov treated regions rich in diversity as clues to the long relationship between people and plants. That relationship is still active. The produce aisle may look permanent, but breeders continue selecting for sweetness, appearance, transport, disease resistance, and shelf life. The perfect supermarket lettuce must survive harvesting machinery, refrigeration, a truck journey, bright store lights, and several forgotten days in your crisper drawer. Flavor is only one demand among many, so return to your salad. The lettuce still carries bitter latex in its veins. The carrot remains a transformed relative of a thin wild root growing among dangerously similar plants. The cabbage is one possible body carved from a salt-beaten coastal survivor. None of them was waiting in nature for humans to discover it. Your ancestors built that bowl without understanding DNA, one seed and one preference at a time. So how did humans turn defensive weeds into your modern salad? They ate the gentlest accidents, saved the strangest survivors, and repeated the choice for thousands of years. Which raises another question. What are the foods on your plate becoming next?